1.
Yes! I love that.
Feel the burn.
Yeah.
Yes, 2020. Yes, I do.
Okay. Unit 6, probability. So we're starting out with counting problems, permutation, combinations. So when you know what kind of, or when to use a counting problem or a combination or permutation, the question is going to ask you, in how many ways can this event occur? So how many different ways can you arrange your schedule? How many different outfits can you put together if you have 3 shirts, 5 pants, and 2 pairs of shoes? How many different combinations of phone numbers can you have? How many different combinations of license plates? How many different social security numbers are there? So there are endless counting problems, and there are several ways to solve them. One way is to actually list out all of the possibilities. You could make a tree diagram or something like that, but I'm going to show you how to do it in your calculator. Here's an example of a tree diagram where if it were saying how many 2-letter codes could you make out of A, B, and C. So you could have A, B, A, C, B, A, B, C, C, A, C, B. And you're counting the last stem. So that's how many different ways you could have that. I've seen it on a free response one time where you've had to make a tree diagram, but hardly ever do they require you to draw any sort of graphic when it comes to probability. You normally would just do it in the calculator. So the first thing is the fundamental counting principle. The fundamental counting principle is you know how to identify it when you can have repeats. So I want you to put that on the top. So you can have repeats. So you can repeat numbers. That doesn't mean you always do, but you can have repeats. So suppose that you have some certain procedure that is broken into in successive ordered stages. So for instance, let's say that you have an iPhone code, something like that. So your passcode is 4 digits long. So 1, 2, 3, 4. I have 4 stages. And within those, how many different digits are possible for your code? No. 0 through 9 is 10. So 10.
4 numbers.
So there's 40 different
10. No.
No, there's 10.
10 times 10 times 10 times 10.
100 million.
So I don't know.
1,000.
That is more than 1,000.
That's
Or maybe it is.
4 tens. That's 10,000.
Yeah.
100.
Why are we doing
1,000.
100?
10,000.
Because you have digits 0 through 9 as possibilities. So you could have,
Let's list out all the possibilities.
yeah, so you could have a code that is 0, 0, 0, 0. You could have a code that's 1, 1, 1, 1. So in this case, my numbers can repeat. So the way that you calculate that is you multiply all of your options together. These are called, so the 4 blanks that I drew, those are my stages, and then the numbers represent the number of options within that stage. So I have 10 numbers as a possibility, times 10 numbers, times 10 numbers, times 10 numbers. You could also write this as 10 to the 4th power. If you want, it's the same thing as saying 10 times 10 times 10 times 10. So another way to write that is 10 to the 4th power. Same thing as saying 10 times 10 times 10 times 10. Another example, so an experimental psychologist uses a sequence of 2 food rewards in an experiment regarding animal behavior. These 2 rewards are of 3 different varieties. So I have 3 types of rewards. How many different sequences of rewards are there if each variety can be used only once in each sequence? So in this case, that's why I said there can be repeats, because that doesn't mean that there are always repeats in the fundamental counting principle. So in this example, would I have any repeats? No, because once I use one of the rewards, I've used it and it's not usable anymore. So in my first reward, I have how many options for rewards? 3. And then whenever I take one away, I now have 2. Yes, exactly.
Wait, does order matter for the counting principle too?
Yes and no. So yes, whenever, it does matter when you can't have repeats. But if you can have repeats, then they're all going to be the same. It's going to be like 10 to the 4th power, so it wouldn't matter what order you put them in because they're all the same number.
So that one you make you just kind of like go down like decreasing.
Yeah, you're decreasing 1 because you've taken 1 away.
Okay.
So if it was like 4, then you go 4, 3, then 2.
Uh-huh. Okay, the next type is a permutation. A permutation is when the order matters. And you also cannot have repeats, so no repeats. A lot of times, so some kind of buzzwords for permutations, things that you would see would be anytime you're talking about codes, rankings, routes, anytime where whatever you are choosing has unequal weight, like everyone has a different job. So for instance, the first person that I pick is doing one job, like the first person I pick is president, and the second person that I pick is vice president. So it matters what order I choose them in because the first gets one job and the second gets another job. So permutation, the order does matter. These are just some examples of things that you see, some different buzzwords, but you have to think, and it's going to be up to you to discern whether it's a permutation or a combination. In your calculator, how we're going to calculate it, it looks like NPR, where N represents the total number of choices. So for instance, if I'm choosing, like how many different 4-letter codes are possible? Well, I have 26 letters in the alphabet, so N would be 26, and then R represents how many you're choosing. So if I said 4-letter codes, it would be 26P4. 4 would be how many letters I'm choosing from the 26. Another way, so this exclamation point, it means factorial. So if you were saying 26P4, then it would be 26 factorial over 22 factorial. But this formula, you don't have to memorize. It is on your formula chart, and you can also always do it in your calculator, so don't worry about the formula. But you do need to know what, in the given scenario, you need to know what N represents and what R represents. Also, 0 factorial equals 1, if you're wondering. I'm going to show you how to do it in the calculator here in a minute. R is like how many you're choosing. So in this example, it says how many 3-letter codes are there using A, B, C, and D if no letter can be repeated. So in this case, how many total options do I have? 4. And I am choosing how many of them? 3. So 4P3. So in your calculator, I want you to get your calculator out. I want you to type in, so in your calculator, you're going to type in the number 4. So you're going to go ahead and type in your N. Then you're going to go to Math, PRB, and then you're going to scroll down to NPR. I don't know what option that is. I think it's like 2 or 3. 2? It's 2. So option 2, hit enter. Then you're going to hit 3. So it's going to look like 4 NPR 3 in your calculator. It needs to look like this in your calculator. 4. So type 4 first. Then go to Math PRB 2. Hit enter and then type in 3. And you end up getting what?
24.
24. So type in 4, then Math PRB 2, and then 3. And then hit 3. So 4P3. Combinations. Combinations are when the order does not matter. So if the order does not matter, then you have to think about when I'm choosing, that everyone is going to get the same job. Another thing is that there can be no repeats. No repeats on this. So order does not matter, no repeats. Some examples of those, like if I'm choosing, you're choosing committees, you spell committees, committees of 3. Or I'm choosing 5 cards. Or so whenever I'm choosing, basically they're all equal weight or like the same job. They all have equal weight. So when you're thinking about it, if I were taking from this class, I said, out of all 9 of you, I'm going to choose 2 of you to clean my whiteboard. So it doesn't matter who I choose first or who I choose second, because at the end of the day, you're going to be doing the same job. So you have to think about, does the order matter or not? If it does matter and y'all are doing 2 different jobs, then that would be a permutation. If you're doing the same job, like you're all 2 of you are cleaning the whiteboard, or 3 of you are going to be in a group and you're doing the same thing, then that would be a combination. And like I said for the last one, the formula does not matter, but N is your total number, however many you're choosing from, and R represents how many you are choosing. So order does not matter. So in this example, how many committees of 3 can be selected from 4 people? So a combination 4C3. So you're going to type in the number 4, then go to Math PRB, I think it's option 3 now, and then type in 3.
4.
And you get 4. Why is this number so much less than permutation?
Order does not matter.
Because the order doesn't matter. So like ABC is the same thing as BAC, is the same thing as CAB. Like these we don't count those 3 times. They only count as 1. And so with the permutation, those would count as 3 separate choices or 3 separate ways. But in a combination, they only count 1 time because they contain the same 3 numbers. Yes?
So is the key just like recognizing in the problem that whether order matters or not?
Yes, that's the most difficult part, is just recognizing whether it's counts or not. Okay, number 4, how many ways can the 4 call letters of a radio station be arranged if the first letter must be a W or K and no letters repeat? So this now has what we call a condition. So I want you to circle the word if. The first letter must be W or K. So that is if. So when you have what we call a condition, you always pull that condition out first. So if I have 4 call letters, I've got call letter 1, 2, 3, and 4. My first call letter, how many choices do I have?
2.
Only 2. Good. Now it says that no letters can repeat. I have 26 letters in the alphabet, but how many do I have left?
24.
You have 25.
25 left because I've used 1, then 24, and then 23.
Wow, this makes everything silly.
So you get 27,600. Now, another thing that you could do, because this is technically a permutation, a second way that you could solve this problem would be, I'm going to pull the condition out first, so I have 2. Now I have 3 letters left. So I have 3 letters, 3 call letters that I am going to choose, and I have how many options? How many letters do I have to choose from? I have 25 letters to choose from. Permutation, 3 of them. So if you did 2 times 25p3, then you would also, if you wanted to check it, you would also get the same answer.
That's insane.
They are both the same thing.
Why do you multiply by 2 on the bottom?
Because I'm pulling out my condition. So conditions always, like if the first letter must be W or K, we call that a condition. And so, do what?
Wow.
And you multiply it by that, yes. So that condition comes out first, and then we do a permutation on what is left. In how many ways can our class elect a president, vice president, and secretary if no student can hold more than one office? So would this be a combination or permutation? Permutation because order matters. There's a ranking. So if we did our class, then it would be 9P3, but we're just going to say N because the class sizes vary.
Oh, so we're gonna have to solve them too, right?
Yes, but they'll always give you an N. How many 5-card hands are possible from a standard deck of cards? Combination or permutation?
Combination.
Combination because I'm just taking 5 cards. It doesn't matter the order. So how many cards are in a deck? 52, and I'm choosing 5 of them. Good. Okay, so that brings me to my next point. I want you at the bottom of this page, or one of the pages, we are going to go over some card facts because the AP test assumes that you know all about cards. So, card facts. Card facts. So, cards facts, you've got 52 cards. You have 26 of each color. So, black and red. You have 13 of each suit. So the suits are diamonds, spade, club, hearts. That should say hearts. Kind of looks weird. Then within that, you have 16 face cards. So ace, queen, king, jack. If you don't, well, it's considered one of the non-number cards. They will normally specify whether they're counting ace or not. Jokers don't count. And then you have 36 number cards. And the number cards are going to be 2 through 10. And then lastly, you have like 4 of each type because you have 4 suits. So there would be like 4 2s, 4 3s, 4 4s. Because you have the 4 suits.
What's your favorite card game?
My favorite card game is probably Speed.
Texas Hold'em. I played Speed.
I love that game. I get so anxious though.
Oh my
Well,
god.
this is like war.
War's actually fun.
Oh, I like that.
Okay, next example. So we are given the digits 5, 3, 6, 7, 8, and 9. How many 3-digit numbers can be made if the first digit must be a prime number? So we've got another condition right here. How many 3-digit numbers? So I've got 1, 2, 3, 3 stages. My first number is going to be my condition. I always pull that out front. So how many prime numbers are there?
1, 2, 3.
2.
5, 3, 7. So there's 3 of them. Now think about this. Can my numbers repeat in this?
No.
Yeah.
Yes.
Yeah. Wait. Yeah.
No.
No.
No, because you have how many?
No.
You can't 'cause they're digits.
No, because here's the kicker. Because I'm given them. So it would be like I'm handing you little Scrabble tiles with these numbers on it. Or I'm handing you little slips of paper and I'm giving you a 5, a 3, a 6, a 7, an 8, and a 9. So since it says given, that means that there's no repeats. What did you say?
That is a good question.
What did you say?
Are there any like keywords or signals?
To learn new language.
Given means no repeats. It'll usually specify, but sometimes it won't. So this is an example where it doesn't specify, but given means no repeats because I'm giving you those numbers. So I pull out the first one. And how many numbers did I have total? 6. I have 6 numbers total. I've used one of them, so how many do I have left? And then I've used another one, so 4. You could also treat this like a permutation, where it would be 3 times, and then what would I put? 5p, not 4. Nope. 2, because I only have 2 left.
Count down.
3 times 5p2. Either one would get you the same answer. You end up getting 60. In how many ways can 9 horses place first, second, or third in a race? What would that be? Permutation, because the order matters. 9p3, 504. So then the last question, it says, in how many ways can a team of 9 players be selected if there are 3 pitchers, 2 catchers, 6 infielders, and 4 outfielders? So they wouldn't just assume that you know about the facts of baseball. So this one is a little bit like you would need to, they would give you the facts of baseball. They don't expect you to know that. They do expect you to know card facts, but out of the 3 pitchers, how many pitchers am I choosing? 1. And then is this a combination or permutation?
I need 1 catcher.
If it's 1, isn't it always a combination?
It's a combination because, like when I'm choosing the outfielders, I'm choosing 3 of them, but they all 3 have the same equal job. Like they're all considered outfielders. So you're going to treat each position as a different combination. So like I'm going to have pitcher times catcher times infielder times outfielder. So 3, choose 1. Then 2, choose 1. Then 6, choose, how many infielders are there? 4. And then outfielders, I have 4 choices and I'm choosing 3 of them. So the main key thing that I want you to get from this is, because I think there's an example in your homework where it's talking about the science club I'm choosing 4 boys and 3 girls. And I have 16 boys to choose from and 12 girls to choose from. You're going to treat boys and girls as separate combinations, and then you will multiply them together. So you're multiplying pitcher times catcher times infielder times outfielder.
Why is there a 1 for both? Can only choose 1 pitcher?
Yeah.
Well, they would tell us.
Yeah, they would tell. So they don't expect you to know. Yeah, they would not expect you to know facts about baseball like this. This is just an example in the PowerPoint. But the only thing that you need to know about is card facts.
Cards are all.
I was confused. So you're saying because in the game of baseball there's 4 infielders.
Right. So what this is saying is like 1 pitcher, 1 catcher, 4 infielders, and 3 outfielders.
I thought that we were trying to just choose 9.
So it's kind of assuming that you know that, but you wouldn't. That's okay. I didn't know that. Okay, so the next part of this is learning about, so there's a little bit of vocab, and then we'll talk about Venn diagrams and just some symbols and things. So first thing is a sample space. Sample space is the collection of all possible outcomes in a chance experiment. So for example, if you roll a die, your sample space, like all of the possible outcomes would be 1, 2, 3, 4, 5, and 6. So my sample space is 1, 2, 3, 4, 5, 6. And you put them in the little curly brackets. So all sample spaces get curly brackets. So sample space is like your total. And then an event is outcomes from the sample space. So if I said rolling a prime number, the event would be 2, 3, and 5. So I'm just choosing all of the prime numbers from my sample space. Or if I said rolling a prime number or an even number, I'm going to list all of the prime numbers and all of the even numbers. And there may be some overlap, but you only write it once. Yes. No.
We were supposed to do this a month and a half ago.
How is 1 not a prime number? I'm sorry.
Well, 1 times 1.
I guess. Don't think I've ever known that. That 1's not a prime number.
What?
It's Is 0 of even or odd?
0 is even.
Wait,
I know.
why is one not wrong?
You can't
One
make
times
it.
1 is 1. Wait, that doesn't even make any sense.
I know. We'll Google that. We'll Google that in a little bit. I would like to know that.
Times 1
is not.
0 is an even number because the definition of an even number is like when you divide by 2, you get an integer as your result. So 0 divided by 2 is 0. 0 is an integer. No,
Is it even guess? It's like a even 3.14.
that's not an integer. That's not even.
What?
Sorry, that's not even.
No.
Hayden, what does it say?
It's a defect. A very confusing answer.
All right.
It starts with the number one
So-
or special.
So an event is when you are taking from your sample space the probability of that happening. You're listing out all of the outcomes of that happening. A simple event is when you only have one outcome. So simple event would be like rolling a 2, rolling a 5.
It's neither.
It's only when you have one outcome.
So with one die, you can only have
Yes, yeah, so you can only roll a 2 once. The only simple event is when you have one outcome. A complement consists of all of the outcomes that are not in the event. So
It's me.
not rolling an even number would be 1, 3, and 5. And the notation for complement is this superscript C. So this is the superscript C. This right here means complement.
So the complement's just everything that didn't happen?
And this E represents event. So you would say event, and then to the subscript C would be complement.
So that's like you saying how, what are the odds that it doesn't do something?
Yeah, so not rolling an even would be all of the odds. So 1, 3, and 5 are the not even ones. Union. Union is the event of A or B happening. So that means that they're in at least one of the two events. So if I said rolling a prime number or an even number, so I'm going to list out all of the primes and all of the even numbers. Like it's at least one of the two. And the notation for union is this U right here means A or B. So the U is A or B. So that means at least one, it's in at least one of the two events. So I'm listing all prime and I'm listing all evens. And you have some that overlap. So for instance, 2 is a prime and even number, but I only list it once. And I'm not going to put 2 and then 2 again. Just list it one time.
So is it an event?
Isn't that what we did in the other one? Did we already do that?
Yeah, it's just showing the example again.
Is it an event like almost like a trial? Like
So
once
what's
you've
the
done
Event
it
is like the outcome of it
Where's the
happening, yeah.
U?
Intersection is A and B happening.
It's not.
So drawing a red card and a 2. And the notation for and is like a rainbow. So like an upside down U, this means and. So intersection is when they both occur. So if I said an event where you have a prime number and an even number, then it would be E equals 2, because it's the only prime even number in this set of 1 through 6. In this case, the only red cards that are also a 2 are red of hearts and red of diamonds. Or 2 of hearts and 2 of diamonds, sorry. Because those are the only 2 that are red. So it wouldn't be 2 of spades and 2 of clubs because those are black. So basically where they both enter, they have to fit both categories. When something is mutually exclusive, another word for that is disjoint. That means that they cannot happen at the same time, that they have no events in common. So you roll a 2 or you roll a 5. So on a Venn diagram, that would mean that they never ever intersect. There is a 0% chance of them happening at the same time. So you cannot roll a 2 and a 5 at the same time if you're rolling one die. And we'll talk more about mutually exclusive in the next class, but just a little bit now. So the main part of this lesson is to talk about what Venn diagrams look like, because those show up a lot on the AP test. Being able to read a Venn diagram and tell me what part is shaded or not shaded.
That sounds pretty easy.
So I have this rectangle. My rectangle is my sample space. So sample space, they use a rectangle to represent your sample space. So that's the entire thing. Then inside, the circles represent events. So that's not how you spell that. Event. So I have event A. So if I were to say A complement, so A to the C power, I would shade everything outside of, so the orange part is my shaded area. It's orange on mine. So I would shade everything except A. So it's everything but A. So that's A complement. This is how you would write it in symbols, symbolic form.
Wait, is ours already shaded again?
Yeah, I think so. Okay, this is A or B. So that means that I shade all of A and I shade all of B. That's how you read. So Venn diagrams, the purpose of them is to decide what is shaded. So I'm going to ask you questions where I have Venn diagrams and things are shaded. And I'm going to say, tell me what's shaded. And then you're going to give me the symbols. So in this case, when all of this is shaded in, like the blue part, I would write A or B. And that would be my answer.
How come we were?
It's
How
pretty
come
good.
we were able to
It's
do
all about the
the
wording.
middle? Because wouldn't the middle be an intersection and not a?
That's what I was.
But when you say A or B, that also includes the intersection.
Okay.
What was she shading on
It's
this?
gonna be all day.
The outside?
Everything.
A complement on the last one. So when you have A or B, you shade all of A and all of B, and also the intersection is shaded. That's A or B. A and B looks like this. And that just means that just the middle section is shaded. And then lastly, disjoint events, what we call mutually exclusive. That just means that your Venn diagram does not intersect at all. So you would not have, I mean, this has nothing to do with shading, but this would look like disjoint events, meaning that their Venn diagram does not intersect. They're just talking back there. It's annoying me.
Hey, shut up.
Okay, so here we have an example. We have an example where now we have 3 different options. So you could take AP Stat, AP Calc, AP Comp Sci, which we don't have that here, but imagine if we did. And we're going to decide, we're going to use the symbols S, C, and CS to represent Stats, Calc, Comp Sci. And we need to decide what area is shaded in whenever so we're looking at this blue part right here. So in your own words, we're not going to do any symbols yet, but in your own words, what part is shaded?
SES.
Comp and.
Comp and so they're taking stat and comp sci, but they're not taking calculus. So I would say stats
Hum.
and
Hump? Oh, like.
comp sci
Computer science.
Stat hump.
and
Not calculus.
not calculus, so calc complement.
We word it like that.
I don't get the
So
compliment.
it's complicated, it's not there.
Yeah.
Or
So you include the calc complement when an entire circle is not shaded. So the entire calculus circle is purposefully not shaded. So that means
so
that
comma means it's not shaded.
right.
So you want us to draw like that, not
We
like.
say and again.
Yeah, so you'll put ands in between. So you have stats and comp sci and not calculus. Yeah, these look weird because you see sucks in there a lot, but okay, let's try the next one.
Nope. Not even responding.
Okay, let's try the next one. So, in your own words,
Ooh, I know it.
they're taking what?
Calculus or computer science.
Calculus or computer science. That was right on the money. So calc
Levels are right on.
or comp sci.
Wait.
Or you could say
Some of
CUCS.
that stat looks good.
But I don't want to write that out
You need to
because
also do,
it looks weird.
the on, the comp as well,
Stop.
since it can also be and, or can we just?
It would be or. The reason why we use or instead of and is because I'm shading all of calc and I'm shading all of comp sci.
Okay. so
But
we
even
just-
though a little bit of stat has some stuff in there.
We don't worry about this stat. No, we don't even mention stat.
So we don't have to say complement whatever.
No, because the way that you would, if you said, like if I needed to include and stats complement would be, that's all right. If I included stats complement, that would mean that this area would not be shaded at all.
Oh, 'cause it's a-
This would have to be completely white. Yeah. But since it is shaded, then we don't have to include the stats complement part of it because some people are taking stats. So we don't include that. We just know that all of calc is shaded and all of comp sci is shaded. So we just say calc or comp sci.
Oh, I know.
Okay, the next one.
I got it.
Statistics or computer science.
And not calculus.
Perfect. So I would say stats,
It's a foreign language.
You know what everything is?
stats or comp sci. So stats or comp sci and not calculus. So and calc complement. So they're either taking stats or comp sci, but they're purposefully not taking calculus because that whole thing is not shaded. Okay, what about this one?
Just
Just stat. So how do I represent that?
computer science or calculus.
Awesome. So I would say stat and comp sci complement or
Doesn't matter which one you put the U.
calc complement. So they're not taking computer science or calculus, but they are taking stats. So stats and not computer science or calculus.
Wait, I thought.
They don't have to be there, but I usually put them in there.
Yeah, that's it.
Then why don't we do that here? Oh, because they're.
Okay, now here we've added some numbers in there. So I first want to shade the area that is statistics or computer science. So what area is going to get shaded?
Area
Whole set.
everything but the 105.
So I'm going to shade all of statistics and I'm going to shade all computer science and I'm going to add them all up
170.
170. So I'm adding up all these to be 170. Okay, next one, statistics and computer science. So what part gets shaded for stats and comp sci?
10 and 10.
So just these two. And so then you would end up
It
getting,
said not calculus using.
200.
if it said and not calculus, then you would just have the 10 and it wouldn't be the 10 at all.
Sweet. I'm the only one.
Statistics or computer science and calculus. So when I have this, I'm going to shade all of statistics. So I'm going to shade all people taking stat. That's all of this whole circle. And I'm also going to shade the intersection of comp sci and calc, which is what number? 20. So this gets shaded as well. So 30, 20, 10, 10, 20. So it's treating these as separate. So this is all of stats. And then I'm also shading the intersection of comp and calc. And since there's an or in between, that means that I shade both areas. So you should get 90. Okay, this one, stats or computer science and calculus. So
All with the intersection.
stats or computer
We do
science
all calculus first.
and calculus. So they must be taking calculus and they must be taking stats or comp sci. So basically, it's the people that are taking two classes, calc and comp sci,
Oh, yeah.
or calc and stat, or calc, comp sci, and stat. So it's this right here. Does that make sense? Like they're having a combination of calc and something. So calc and stat, calc and comp sci,
Wait,
calc.
but
That's
how
it.
come in the last
Oh,
one we
shoot.
did all of
Because it says and.
and
So that means they have to be taking calculus and they have to be taking either one of these.
and means
Oh,
it's
so they're not
a choice.
separate. It's like that with that.
Right. And that's because this says and, so that means you have to do the intersection. On the last one, it said or, so that means I shaded both of them. So then this would be 50. The end.